Alright, welcome to another video. Here we will be looking at another method for finding the correlation coefficient, that's the Spearman's rank correlation coefficient. The Spearman's rank correlation coefficient is a non-parametric measure used to assess the strength and direction of the monotonic relationship between two ranked variables. Again, there are some problems when data exhibits some relationship but not linear correlation and cannot be described by Pearson's correlation coefficient. In such cases, the object or the individuals may be ranked and arranged in order of merit or proficiency on two variables when these two sets of ranks have agreement between them. We measure the degree of relationship by rank correlation. For example, the evaluation of a group of students on the basis of leadership ability, the ordering of women in a beauty contest, or students ranked in order of preference. Spearman has developed a formula called the rank correlation coefficient to measure the extent or degree of correlation between two sets of ranks. When do we use the Spearman's rank? The first one is when data are ordinal or ranked, or when data are not normally distributed. The relationship is what between these variables are monotonic. That's they are consistently increasing or decreasing, but not necessarily linear. Also, when Pearson correlation assumptions like the normality, continuous data are violated. Also, as we will be solving example, you come across the following types of problem where the actual ranks are given, that's they've already ranked it, and you'll be asked to find the deviation, and later on you square the deviation. Where actual ranks are not given, that's when you would have to find the ranks yourself. Then you would have some equal ranks or some tie in the ranks. We would look at each of these types of problem and try to solve example on each other. Then the formula to calculate the rank correlation is given by 1 minus 6 sigma d squared n into bracket n squared minus 1. Alright, this formula can also be rewritten as R is equal to 1 minus 6 sigma d squared. When we multiply this n by the n squared, we are getting n cubed minus n. So either this form or this form, they are the same. Alright, let's look at the steps to compute for your R under the rank correlation. First, we need to create a table by listing the two given data sets. We assign ranks to the data set if it is not given. Ranking is achieved by giving the ranking 1 to the biggest number in the column, 2 to the second biggest value, and so on. The smallest value in the column will get the lowest ranking. This should be done for both sets of measurements. In case of equal ranks or tie in ranks, tie scores are given the mean or the average rank. For example, in a data set of observations, 3 observations have similar values of 20 each, and they possess 4th, 5th, and 6th rank in the group. Instead of assigning the 4th, 5th, and 6th ranks, the average of the 3 ranks, that's 5, is to be assigned to each of them. So the average meaning that the 4th, so we are going to 4 plus 5 plus 6 divided by 3. So we are getting 15 divided by 3, which is 5. So instead of assigning each of them the 4th, the 5th, and the 6th value, we assign the average, which is the mean, to each of the values. When we are done, we find the differences for the ranks, that's the D. Square these differences to remove negative values and then sum them up. Calculate the coefficient as R using the above formula. The answer will always be positive 1. That's we are having a perfect positive correlation, or negative 1. So more like the range for the first example we did, the first video. In the first video, you have between -1 what is +1. That's where your R should lie. Alright, let's look at some illustration. I told you that we already mentioned that for the rank, you can be given a question where your actual ranks are given, where actual ranks are not given, and where equal ranks or tie in ranks. So we are going to take each one of them and try to solve some examples. So illustration, where actual ranks are given. 10 competitors in a beauty contest are ranked by 2 judges in the following order. Calculate the Spearman's rank correlation coefficient. So you have the competitors, you have the first judge and the second judge. We have A to J. And this ones, they are the actual ranks. So there's no need for us to compute for the ranks. Right, we just go ahead from step 4 to find the difference of the ranks. When you're done finding the difference, we square the difference to remove the negative values. Then we apply the formula to find R. So we would be solving this one in our next video.